Hello students, today in this video we will learn about electric circuit and electric switch. Let us go through the video.
You must have seen houses decorated with strings of lights during Diwali and Christmas. Have you ever noticed how the bulbs in a string glow in harmony? And if one goes off in the middle of the string, the others too tend to go off. This happens because electric current stops flowing through the wires. Let's perform a small experiment and see how current flows in a simple electric circuit. You will need a light bulb, an electric switch, connecting wires, and an electric cell, such as a pencil cell or a battery. Observe the electric cell carefully. The end marked with a plus sign is the positive terminal, while the end with a minus sign is the negative terminal. With the help of the wires, connect one end of the bulb to the switch and the other end to the cell's negative terminal. Connect the other end of the switch to the positive terminal of the cell. Ensure that the switch is off when you make the connections. Once you have safely connected all the parts, you can close the circuit. Click the switch to close the circuit. When you put the switch in the on position, you complete the circuit. Current starts flowing from the positive terminal of the electric cell, reaches the bulb, and then returns back to the cell through the negative terminal. When the current reaches the negative terminal of the cell, the bulb starts glowing. Let us put off the switch and see what happens. Click the switch to open the circuit. When you put the switch in the off position, the circuit opens up and current stops flowing through the wire. Hence, the bulb goes off. Imagine what will happen if we interchange the terminals of the cell. Click the electric cell to reverse the terminals. Now, let's put on the switch to see the result. Click the switch to light the bulb. When you reverse the terminals of the cell, the current still flows from the positive terminal to the negative terminal when the circuit is closed. Electric circuits should be complete for the current to pass through them. This means the wires must be connected in a full loop from the positive terminal to the negative terminal of the electricity source. Any break in the circuit will disconnect the flow of electric current. For example, if the wire breaks, the current will not be able to flow from the positive terminal to the negative terminal. Hence, the bulb goes off. Have you ever had this strange experience of turning on the switch of a light bulb and see the filament flicker and go off in a jiffy? You might think something went wrong with the bulb. Well, that might not always be the case. The filament of the bulb might still be intact. So what could the problem be? Let's do a small experiment to find out. You will need a torch bulb, an electric switch, a connecting wire, and 3 electric cells. To begin with, build a simple circuit by connecting one electric cell to the bulb and the switch. Now, click the switch to light the bulb. The bulb glows when electric current flows through the entire circuit. Let us add one additional cell to the circuit and see what happens. Add a second cell to the circuit by clicking it. Now, click the switch to close the circuit. You can see that the bulb glows more brightly when an additional cell is added to the setup and the circuit is closed. This is because the two electric cells that now form a battery are providing more current in the circuit. This makes the bulb filament glow more. Now, let us add a third cell to the circuit. Add a third cell to the circuit by clicking it. Now, click the switch to close the circuit. When another cell is added to the circuit, the bulb glows vigorously and the filament inside burns and breaks. This happens because the bulb cannot withstand the high amount of current passing through its filament. The bulb with the broken filament is said to be fused out. What happened to that bulb could very well happen to any electrical appliance. What if you were watching an exciting match and there was an electrical surge and your TV suddenly blew up?
Oh no!
Let's take a simple circuit and see how we can prevent electrical devices from blowing up. Add a small strip of a metal with a low melting point, such as zinc, to the circuit. This metal strip is called the fuse. The entire line current must pass through it before reaching any of the appliances. If the fuse is rated at 2 amperes, it will pass 2 amperes, but no more. A line current above 2 amperes will melt the fuse and break the circuit. The fuse cannot be reused once it burns and breaks. The high electric current never reaches the bulb, keeping it safe and intact. So now you know how the fuse blows up. First during a power surge, protecting the rest of your household appliances. And once a fuse goes off, you can replace it with a new one.
Electric switch. In our homes, we use switches to turn the lights on or off. A switch is a device used to break or close an electric circuit. By building a simple circuit, we can take a closer look at how a switch functions. For this, we will need a wooden plank, a dry cell, a torchlight bulb, 3 pieces of wire, 2 drawing pins, adhesive tape, and a plain wire paper clip. Begin by pressing the 2 drawing pins into the wooden plank. Strip the plastic from the ends of each wire so that the metal center is exposed. Using the tape, stick one end of the piece of wire to one end of the dry cell and wrap the other end around a drawing pin. Connect a second piece of wire to the opposite end of the dry cell with the tape. Then wrap the other end around the base of the bulb. Finally, fasten one end of the third wire to the bottom of the bulb and wrap the opposite end to the drawing pin, which has nothing connected to it. We have now built a simple circuit, but one which has a gap in it. To bridge the gap, let's use a switch. To make the switch, unfold the paper clip. Hook one end to one drawing pin and leave the other end free without touching any pin. Let's see how this switch works. If we move the free end of the paper clip so that it touches the other drawing pin, the circuit closes and the current will pass through the wires, lighting the bulb. Once the clip is moved back away from the pin, the circuit will be broken. meaning current is no longer passing through it and the light will go off. The switches in our homes function in a way that's similar to a paperclip switch. Summary: a switch is a device that is used to break or close an electric circuit. When the circuit is closed, a current is able to pass through. Current cannot pass through a broken circuit.